All right, today we're going to learn about reflection and the law of reflection. So first of all, the first thing you need to know is that when a beam of light reaches the boundary between two media, some of the energy will transfer into the new medium, and some of the energy will bounce or reflect back into the original medium. All right, this actually happens with any wave. Anytime a wave moves from one medium into another, some of the energy gets converted into the new medium, some of it gets bounced back. Simple examples of this would be a wave hitting the shore, right? As the wave rolls up, hits the shore, it's going to bounce back, so some of the water gets sort of sloshed back into the sea, and the shore or the cliff absorbs some of the energy too, and this is what causes erosion, right? Is that the shore or the water beating against the beach or the shore or the cliff or whatever over time erodes away the rock or whatever. Okay, so a wave changing mediums will reflect or bounce back. Okay, now you guys all know from bouncing a ball that if you drop a ball straight down, if you take a ball and drop it straight down, then it will bounce straight back up. Okay, you also probably know, if you've ever played basketball, that if you throw a ball at the ground this way, that it will bounce up this way, right? Okay, so you've got this bouncing is very similar to what we're going to call reflection here as we do light. Okay, now the law of reflection tells us that the angle that the beam of light or wave or basketball comes in at is the same as the angle that it goes out at. Okay, however, there's a very specific way that we measure the angles here. So what I just marked here is not, you'll see in a minute, is not going to be 100% accurate. Okay, so anyway, I'm getting ahead of myself. Here we go. Here is the law of reflection. The law of reflection says that the angle of incidence equals the angle of reflection. Okay, in shorthand, it looks like this. This little dude here, it's a circle with a line through it basically, is the Greek letter theta. And in math and in science, we very often use the Greek letter theta to measure an angle. Okay, so if you say theta is 30 degrees, you're telling me the measure of the angle. Okay, so this is saying the angle of incidence equals the angle of reflection. Okay, so you will see me write this, angle of incidence equals angle of reflection all the time, because that is the law of reflection. All right, so at this point, let me just show you a quick example. No, I'm getting ahead of myself. I'm going to come back to that example. All right, so here we go. A couple terms that you need to know. All right, so the first term you need to know is you need to be familiar with the term boundary. All right, the boundary is the line that separates the two media. All right, so in the case of the water hitting the shore, this line here, the face of my cliff, would be my boundary, right? Because as your wave comes in, slosh, it bounces back. That is caused by the boundary between the water and the cliff. Okay, we're going to be talking about light. So for us, light bounces off of objects, mirrors, glass, anything really. It doesn't even need to be, shiny or smooth or whatever. Light bounces off of everything. That's why we see stuff. So if you're imagining a mirror, so here's my mirror. That line there, that surface of the mirror, is going to be my boundary. Okay, now if you've got a beam of light that comes in, it's going to hit at a specific point. That point is called the point of contact. Right? That is the point where a ray of light or a beam of light strikes the boundary. All right? Now, the most important part is, or maybe not the most important part, but something that is new that you might not be aware of is, this idea here of normal line. All right? When we're doing optics, anytime optics means study of light, basically, and vision. So when we're talking about light, anytime you measure an angle, you have to know what your normal line is. All right? So the normal line is an imaginary line drawn perpendicular to the boundary through the point of contact. Okay? So if you don't remember, make a note. Perpendicular means 90-degree angle, right? Okay? So that is what the normal line is. So on my drawing up here, let me clean up this drawing. It's a little bit muddled. So we've got the surface of our mirror. we've got a beam of light coming in and hitting the mirror right there at our point of contact. So my normal line is going to be a line that is perpendicular to the boundary and through the point of contact. So it's going to look like this. Dot, 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 dot. So that is my normal line. My point of contact is this little blue dot right there. I wish I hadn't just drawn an arrow there because I don't want you to think that's a beam of light. And then this red line is, your beam of light coming in. Okay? Now, there are also two angles that you need to be aware of, specifically the angle of incidence and the angle of reflection, right? So those two angles are measured in a way that isn't totally intuitive. And to be honest, I've never seen a good reason for why these angles are measured this way. But anyway, you don't care about all that, so here we go. The two angles are the angle of incidence, theta I, and the angle of reflection, theta RE. So the angle of incidence is the angle between the incident beam, the incoming beam, and the normal line. And the angle of reflection is the angle between the reflected beam, the outgoing beam of light, and the normal line. Okay? So let me show you sort of a simple example here. We're going to talk about basketball for a second. So what we've got here is a video from Howe. This coach over here is talking about how to pass a basketball, doing I always call it a floor pass. It's a bounce pass. So here we go. The kid on the right side of the screen is going to bounce the ball to the kid on the left. Boom, boom, and then they go back and forth a couple times. But what I want you to notice is that when they throw it, more or less the ball hits the ground directly in like halfway between the two of them, right? So here you can see I've paused the video, and what has happened is this kid over here has just thrown the ball, and it has hit the ground here, and it is in a minute going to bounce right back up to this kid here. All right? So the law of reflection tells us that the angle of incidence equals the angle of reflection. So the first thing we need to do is identify our boundary. So our boundary is going to be the floor. So there's the surface of the floor. That's our boundary. Okay. The next thing you need to do is identify the point of contact. The point of contact is right here where the ball hits the ground. And then you need to identify what's called your normal line. So your normal line would be a line that pretty much just goes straight up and down. All right. Now, any rational person would then say, oh, look, the angle that it goes in at is the same as the angle that it goes out at. Unfortunately, that is not the way that it is done. When you measure your angles, instead of, in this example, rather than measuring the angle between the floor and the path the ball takes, you measure the angle between the normal line and the path the ball takes. So in this example, this angle right here is my angle of incidence, and this angle right here is my angle of reflection. Okay? So those of you who are mathy will know that, how do I want to say this? That this angle here and this angle here add up to 90 degrees, right? So according to the way that I've labeled it, my angle of reflection does in fact equal my angle of incidence. Okay? And then these other two angles, which I am now drawing in green, these two angles also happen to be equal. They just don't have fancy names. Okay? So those two angles that I just drew there in green, here and here, kabam and kabam, those two angles are equal. They just don't have names. Okay? So hopefully that makes a little bit of sense. All right, so let's go back to optics. In optics, it's going to look like this. So it's going to drive me, it's fine. Okay, so what I've got here is a beam of light. This little dude here is my laser. All right, and the beam of light is coming out of the laser. Down at the bottom, this little purple boundary here represents our mirror, and the light then is bouncing out. So this right here is my incident beam. And then you can see over here that you've got this reflected beam over here. That is my reflected beam. Okay. The boundary is this line down here at the bottom, which it's not going to let me draw. So that little blue line down there is the boundary. Holy schmoly. That is the worst spelling anyone has ever done. I don't know what I was trying to do there. Boundary. There we go. Okay, and then the point of contact is this little dot right here. So in this drawing, here's my angle of incidence, here's my angle of reflection. And those two angles are equal. All right, now it turns out that it works for any angle, so that if I move my laser, you can see that my angle of incidence gets bigger, so does my angle of reflection, right? If the laser goes straight down, the reflected beam comes straight back. If my angle of incidence is very big, my angle of reflection is very big. So now, here's my angle of incidence, here's my angle of reflection. All right? So that's the law of reflection. Now, unfortunately, in order for us to do anything with this productively, you got to know how to use a protractor. So here we go. We're going to do that real quick. All right? So, okay. So the way this is going to work is on your homework, and in fact on labs, you're going to be given a situation like this, where you're going to have a boundary, and you can see this black line here is the boundary, so that might be the surface of a mirror or whatever, and you'll be given an incident beam of light, a beam of light that's coming into the boundary. And the question is going to be, where does the reflected beam go? All right, so to figure this out, it's a two-step process. The first step is you have to find your normal line. So what I want to do is I want to draw a line that goes through my boundary through the point of contact. All right, so doing that is going to require that you use a protractor. So what you want to do is take your protractor and put it so that your sort of zero marker, so that your zero marker is right there at the point of contact. All right, and then what you're going to do is you're going to rotate it until the zero lines line up with the boundary. Like that. Okay? And then what you're going to do is you're going to take your pencil and you're going to make a little mark right there at the 90-degree mark. And then you're going to use your ruler and make a line from the point of contact through the 90-degree mark. Okay? So I'm going to move my protractor out of the way for a minute, and I'm going to grab my ruler here. For me, I have cheater straight lines, but basically you're going to draw a line that goes this way. So that dotted line that I just drew there represents my normal line. And technically, you should actually extend it both directions, which there isn't really an easy way. Oh, that works. There we go. It should really extend on both sides of the boundary for reasons that will become clear later on. All right, so once you've done that, bring your protractor back. And now what you want to do is you want to measure the angle between the boundary and the incident beam. So I'm going to, once again, I'm going to rotate my protractor, but this time I'm going to line it up with the normal line. So I've got my protractor lined up with the point of contact here. All right, and what I'm going to do is I'm going to measure that angle there, because that is the angle between my normal line and my incident beam. Okay, so to measure the angle, you literally got to count. We're going to start here, and I'm going to go 10, 20, 30, 40, 50, 60, and it looks like it's pretty close to 65 degrees. It is a little tough to tell with this, but so what I know now is my angle of incidence equals 65 degrees. Okay? So let's clean up the drawing a little bit here because it's getting a little bit cluttered. Drawing the angle, that's my angle of incidence. All right? So now the question is, where does the reflected beam go? So to find your reflected beam, what you're going to do is you're going to take your protractor and you're going to spin it around 180 degrees. Make sure that your point of contact is the center of your protractor. And make sure that your normal line is lined up with your zero line. And then you're going to make a mark at 65 degrees. So I'm going to take my pen, I'm going to put a little mark right here at 65 degrees. And then I'm going to grab my straight edge, and I'm going to draw a line from my point of contact out. And there we go. So now my angle of reflection is also 65 degrees. All right? So that's how you're going to solve the problems. The thing you guys are going to struggle with here, what I tend to find, is that people do struggle a little bit with using the protractor, and that's really one of the things I'm just going to have to sit down and kind of walk you through it. But that's the deal, all right? So hopefully for a lot of you that answered your questions, but if not, there you go. All right, so there's the final drawing. I guess I should clean it up here. There you go. All right. I almost asked if you had questions, but this is a video, so have a good day.